welcome everyone for this international conference, talking about Institute of Research and Journal Forum, and also the allied organization, the IRAJ, Institute of Research and Journals organization. Okay, my audio is low. Is it audible? I can see some. Is it fine?
Yes, sir.
Thank you. Thank you. Audible but low. Okay. Is it fine now?
So you're perfectly audible.
Thank you. Thank you, Pratham. Thank you. Others, please turn on the video. In the meantime, we have around 10 participants to turn on the video. Let me name them out. Adi, Karla, Ram, please turn on your video. Adi, Karla, Vamshi, Abhiruchi, Nandini. Please turn on your video. And Fatah, Saidi, Nandini, Yashna, Karkera, Alnor, Praveen, Rakofi. Please turn on your videos. So talking about the organization is a decade-old organization, international organization, conducting conferences across the globe based out of Dubai. And the organization has around 10 journals in the field of science, technology, management, humanities, and medical science. And till now, more than 1,000 plus conferences have been conducted by the organization, and also the organization's has conducted published more than a lakh of papers in this journey in these journals till date. So this is some small statistics with respect to the organization, right? So with these few information, right, of the organization, I welcome everyone for this international conference. So without wasting much time, we will come back to today's theme of ACN conference. We have around 22 participants for the day, right? So we let us quickly go ahead and start with today's conference. And as a theme of the conference, it is basically of interdisciplinary in nature, right? So it's an added advantage for your participants for us to collaborate and to connect each other across the globe, and also to check what exactly research happening in the different field, right? You can take this platform to connect with the different participants and note down their email addresses and write down to the and collaborate and work together is what I personally feel. So we will, without wasting much time, I call upon, we will start with today's session. Before that, I'll have a quick group photo of everyone. I request everyone to kindly, keep your some forces or something. So let me just take a quick photo for the day. Yeah. Let me take one or two more. Let me take one more. 1 second. I'm just saving this. Yeah, two. Thank you. So we have around 22 participants for the day. Request, as in the interest of time, we can have maximum of 8 minutes for each participants, and we can take up the questions offline. That is, if if we interact or discuss for each participant's question and answers over here, everyone start asking question. It will elaborate for hours together. So to cut short that, what I personally feel is you can share your email address in the chat box, and we can connect offline. Participants can connect offline, so that if you have any queries, you can mail them, note down their email address, keep a sheet of paper, write down their title and topic and about them, and then you can mail and collaborate, basically, is what I personally feel, right? So with these information, or with these few points, right, without wasting much time, I'll call upon the first participant of the day, right? And also the thing is, as I keep maximum of 8 minutes per participants. And I request the participants, you can turn on the video during the presentation and restrict yourself to present maximum of 8 minutes, right? So with these inputs, I call upon the first participant for the day, that is PARUL DHINGRA, PhD scholar from Amity University, Havana. Influence of hope and resiliency of risk-taking behavior amongst independent organizations, traders. Do we have them present here?
Yes, sir.
Yes, Parul. Please share your presentation.
Is my screen visible to all?
Yes, please go ahead.
Hi, good afternoon. Without much further ado, I'll just introduce the subject area, which is trading psychology. So, as a part of the subject area and to continue with the research in this new area of performance psychology, we studied the influence of hope and resiliency on risk-taking behavior amongst amongst traders, and these traders were selected from organization settings and for the ones who trade individually. As a part of the study, we actually wanted to approach it from the purpose of developing hiring models and career counseling models for the people who wish to go into the trading as a profession, and as a part of organizations to develop hiring models when they take in traders. So we wanted to explore what all psychological variables actually align with things that are very important to trading. And one such variable is risk taking. So the sample was a combination of a sum of 436 independent and organizational traders combined, which came across, which actually participated in this research through online form filling, and they filled in these psychometric tests. For hope, they filled in the adult hope scale, the brief resiliency scale for resiliency, and in order to check themselves on risk-taking behavior, they filled in the general risk propensity scale. As I shared previously, the purpose of this research was to explore the predictive relationship between hope and the two sub-factors of hope as per the Snyder's theory of hope, agency and pathway, resiliency with the risk-taking behavior. This was to develop hiring and career selection models. And the entire idea of this has been to enhance trading and performance psychology research. Correlation and regression analysis was done amongst these variables, and the key results primarily showed that total hope as a variable, which is not only a combination of pathway and agency, came out to be a very significant predictor of risk-taking behavior. The relational analysis was very significant. However, the two sub-factors showed different kind of variation with risk-taking behavior. Pathway per se was very significant, and agency, the ability for one person to feel how much I am involved in a certain scenario, was not very significant when it came to risk-taking behavior. Now, resiliency, the aspect of somebody to come back to themselves, to come back after a very difficult scenario, came out to be not significant, surprisingly. It sort of missed the mark of significance when it came to correlation with risk-taking behavior. So basically, the idea here was such that the study showcased how individuals with higher general hope are more inclined towards risk-taking behavior. People who generally, as a person, are very hopeful, they're more inclined to take up risks under uncertain environments such as trading itself. So performance psychology also extends to areas of military psychology and sports psychology. So somebody who is very hopeful, all in all, as a person, is likely to take more risks, be it in the field of sports, military, trading, whatsoever. But when we understand hope, it's just not one comprehensive variable, it's a combination of multiple things. Wherein pathway, which is the goal planning part of hope, that came out to be very significant and supports calculated risk taking. But agency, the idea of relying on yourself for something risk-provoking was not very significantly related. And so wasn't resiliency. So this entirely highlights the selective role of hope in risk-taking and risk-oriented behavior. Its implications for organizations and also for individuals who are planning to take up trading as a professional career. This study would actually help in enhancing the training programs, focusing on goal setting and planning for the organizational enhancement and self-career enhancement. The hiring in the organizations and career selection guidance for independent traders would also be one of the very major organizational implications. Use of psychological profiling. These days, people look for their interests and fail into understanding as to what all aspects are important psychologically while they're choosing a certain career. So psychological profiling would, using this study, would also help to support the decision makers. This would also help in developing resilience and hope-based workshops and training modules for any kind of high risk spaces, such as military as well as sports as a field. If we plan on job trainings, if they are based into resilience and hope, they are likely to really help the people and the professionals take more and more calculated risks while they are doing their jobs. As a part of the conclusion, I think I'm running too fast, but I'm in time to conclude this entire study. Hope, particularly the pathway component of hope, significantly helps in predicting risk-taking behavior, be it in whichever profession. This actually highlights the need for tailored psychological development strategies in high-pressure organizational contexts and even self-provoking career contexts. That is it from my side. Thank you. Over to you, Ravi sir.
Good afternoon, everyone present here. My name is Abhiruchi Bharambe, and I'm going to present my paper along with my co-authors Nandini Hazarika, Vedant Balika, and Yashna Karkera. So our paper is titled Unleashing Sentiments Through Textural Analysis, which mainly focuses on the facial emotion recognition. So introduction. So basically, facial emotion recognition, it's a powerful and non-invasive tool which has various applications like video surveillance or anti-spoofing or mental health diagnostic. However, the traditional appearance-based models, they often missed out certain like subtleties in the emotions due to, let's say, the lightings in the images or the different facial poses or maybe cultural diversity. So to address these problems, our project incorporated advanced CNNs and transformers as well as denoising techniques so that we can like deal with the data better and handle the noisy data more effectively. And moving on to the abstract. So usually FER systems, they faced various issues like let's say the dominant ones where the data was scarce or the computational cost was high or the generalization was poor. So our research tackled these problems by using image augmentation techniques, denoising, and state-of-art techniques like GANs to generate like diverse emotional expressions, and eventually to improve the accuracy and interpretability, and which has various applications in, let's say, mental health or human computer interaction. Then the problem statement. So facial emotion recognition, it's critical in various fields, like I told, mental health or human computer interaction or video surveillance. But the conventional systems, they focused on the geometric features and they often missed out certain emotional cues. This is where we step in, like we shift the focus to textural analysis, where we analyze the textures on the face, like the eyes, nose, and the mouth, to capture more micro expressions so that the whole emotion detection is more accurate. Then these are the functional requirements. So basically we have worked on a front end along the side where we just practically take an image and like a series of images, and then we determine the dominant emotion. Then yeah, we have done a literature survey of around 15 plus papers, and yeah, the flowchart. So practically, we collect the data set and images initially. So we have worked with the CK plus data set, which has around 30,000 images. Then we performed image augmentation, rescaling, and pose and light normalization so that we can improve the data set or increase the diversity. And then image pre-processing, like to improve the image quality, like removing the background or detecting the edges so that we can like more accurately determine what emotion the face is showing. Then we perform two types of extraction, feature extraction, like filter based and texture based, which I'll be explaining further. Then we splitted the data into training and testing, and the training is a fine-tuned CNN model and a transformer model, which is trained on the training data, and then we evaluated it. And this is a data flow diagram which shows how the data flows throughout the system. This is basically the backend part, which has all these processes, which I'll be explaining further. And a UML diagram which shows how the whole system structure or the behavior, like we can say there are various packages over here and various classes over here, and how each classes are interconnected. And yeah, so moving on to the feature extraction technique. So the first one was filter based. We explored these three: Fisher score, dispersion score, and Passiluca metric. So in Fisher score, we basically use something called as a Fisher linear discriminant analysis, which minimizes the intra-class distances and enhances the inter-class mean difference. And in dispersion score, we used like the standard deviation and the variance to like handle the outliers more effectively. And in Passiluca, we use chi-square and cosine similarity tests so that we can like eventually employ fuzzy entropy metrics to select the relevant features and eventually classify the emotions. Then we explored around 8 texture-based techniques like HOG, Gabor filter, SIFT, LBP, brisk, spatial pyramid pulling, etc. So HOG and LBP, they basically extract all the edge orientations and the local textural patterns. And Gabor filters and heraldic features, they capture the frequency and the relations in the textures like which are present in the images. Then Sift, Brisk, and Zernike, they basically capture key points in the images and then they compare it to like other images in the data set so that we can classify if that image belongs to the same emotion. And yeah, this was a comparison of all these techniques. And as you can see, local binary patterns gave us an accuracy of 97.46 and Fisher score gave us the least of 69%. So our whole methodology was we basically tried a baseline model with Google Inception Net model, which gave us an accuracy of around 56, which was less. And from the loss entropy curve, we got to know that there was a lot of high variance in the data set, like in the system, because the disgust emotion was classified as anger and sad was classified as neutral. So to improve this, we combined FER with CK plus so that the number of images can be increased. And then we used efficient net model. Then eventually the accuracy was increased up to 76%. And then after this, we tried something new, like generating random expressions or random images or like new images from existing images. So this is where we use GANs, which consists of a generator and a discriminator, where the generator takes a random sample, which is called as the latent vector, constructs an image from it, and the discriminator takes that image, compares it with the images in the data set to check if it's real or fake. And yeah, so there were certain problems over here, like we couldn't deal with multi-class images or generate multi-class images. So to tackle that, we used encoders and decoders, where the encoder takes the input, generates a latent vector, and the decoder takes the latent vector and generates an image of another class, another emotion, sorry. Then this were the original images, like cartoon images of various expressions. And Yeah, these were the ones on the right side are the images that were generated by combining different emotions. Like the second column shows anger and sadness, the third one shows joy and disgust, the last one shows fear and surprise. But we are still working on it. For the future work, so we plan to improve our front end so that we can maybe let's say if your dominant emotion is sad, so we can recommend you some mental health resources, or we try to we want to explore more techniques so that we can improve the accuracy, like using active appearance models or 3D GANs, or let's say pose estimation, etc. Yeah, thank you.
So good afternoon, everyone. I'm Ansara, here to share a brief presentation about our study titled Analyzing Variation in Indoor PM 2.5 Pollution and its Correlation with Environmental, Temporal, and Anthropogenic Factors using Statistical Methods. The main author of the paper is Ishfaq Ahmed Shakladar, and I'm the co-author, Anzara Zabin, also the presenter. The air quality in Bangladesh, particularly in cities like Dhaka, is a major concern, as evidenced by the high AQI levels. A recent news article highlighted that Dhaka has experienced only 14 clean air days over the past 5 years, underscoring the significance of the issue. On the right, you can see that in almost all the major cities, the cities have very unhealthy or unhealthy AQI category, and the responsible pollutant is always PM 2.5. Our study aims to contribute to this conversation by shedding more light on the current air quality situation, especially in the residential environment, as people stay more time indoor than outdoor. For our study, we installed purple air sensors in households across different locations in Dhaka city to monitor air quality. These low-cost air monitoring sensors offer the advantages of affordability, convenience, and the ability to provide detailed ground-level assessments, making them a valuable tool for tracking and addressing air pollution. Our objectives are to compare indoor and outdoor PM 2.5 concentrations across different locations in Dhaka using statistical tools, determine temporal and seasonal variation in pollutant concentrations, and assess the influence of environmental and anthropogenic factors on outdoor air pollution. So we selected different sites in Dhaka where purple air sensors were pre-installed and collected data over a 1-year period. Existing literature suggests that cooking, the use of candles, and chemicals used for cleaning are the key contributors to indoor air pollution. Dhaka and Western Chittagong are identified as hotspot for air pollution, where areas like Sylhet and Rangpur are comparatively cleaner. Ventilation system plays a significant role in the variance of indoor PM 2.5 levels. Now let's dive into our methodology. For our data collection, Visual Crossing, an open source weather monitoring agency, provided meteorological data such as rainfall, wind speed, and other parameters. Furthermore, typical travel durations between two arbitrary points were obtained from Google Traffic API, which was used as a proxy for travel volume, and purple air sensors were installed as mentioned before. The data found from purple air sensors are mean hourly averages, which we have processed using different softwares in order to use for our research. Among them are Python and Microsoft Excel were prominent data processing tools. Several statistical tools were used to conduct proper analysis to get to the findings. Some of them were data transformation, log normal transformation, PRT test, ANOVA test, LSD test, confidence interval test, Mann-Whitney U test, and regression analysis. Now let's look into the research avenues that we invested in. At first, we saw the descriptive statistics of the selected sites and then compared different PM levels among the sites. Then we thought about the variation of PM 2.5 concentration at different times of the day. Then we assessed if cooking time had actually any proper effect on PM 2.5 levels or not. Then we compared the indoor versus outdoor PM 2.5 concentration. After that, we chose to study the effect of dry and wet seasons on PM 2.5. And at the last, we chose to see the influence of nearby traffic and different meteorological parameters on indoor PM 2.5 concentration. Now let's look at the findings. Outdoor PM 2.5 concentrations were maximum in Shahjahanpur, while outdoor concentrations reached up to 101.05 microgram per meter cube, where indoor levels peaked at 64 microgram per meter cube. Observations indicated that nearly 100% of the time, PM levels exceeded the WHO specific standard, which is only 5 microgram per meter cube. The infiltration of PM 2.5 from outdoor to indoor environment was also significant, with up to 97% of outdoor particles entering indoor spaces. Now, if we compare, if there is any variation among different sites, we performed ANOVA and Fisher LSD test. The test illustrates a comparison of PM level. It demonstrated that despite being in the same city, particulate matter varied significantly between different locations. It actually indicates the influence of localized factor on air quality across various sites. Then we divided each day into 4 parts with 6 hours each. Temporal analysis revealed that PM level is less during the early morning. Particularly between 4 a.m. and 10 a.m., we can see clear depression in concentration in 8 sites out of 10 around this time. Now, if you wonder if PM concentration is higher during cooking, which theoretically it should be, confidence interval actually determined that particulate pollution does not significantly rise during cooking hours, which we considered 10 a.m. to 2 p.m. It suggests that cooking activities may not really contribute substantially to indoor PM levels in this context. Now, if we compare the indoor versus outdoor PM 2.5 concentration, we see that outdoor PM levels were generally higher than indoor levels. However, during periods of high infiltration, indoor and outdoor concentrations were found to converge, reflecting the significant role of outdoor air quality in determining indoor conditions. We also analyzed the data based on dry and wet seasons. PM concentrations during the dry season were significantly higher than those in the wet season, with seasonal ratios often exceeding 2 to 3. The red color represents the dry season, and wet season is represented by the blue. It highlights the substantial impact of climatic conditions on PM levels. Then regression analysis was conducted to evaluate potential influence of nearby traffic on PM levels. Simple linear regression found no significant effect on traffic on indoor PM concentrations. Now we wanted to see the relationship between indoor PM levels and different meteorological parameters such as temperature, dew point, humidity, wind gust speed, wind speed, sea level pressure, and cloud cover. We find the inverse relation between wind and particulate matter and positive correlation with pressure. Here we can see the scatter plots of PM 2.5 concentrations with various meteorological parameters. Here you can see the summary of our findings. For our limitations, we have to state that the meteorological data was obtained from a weather station located far from the selected study sites, which may have impacted its representativeness for site-specific analysis. Next, direct vehicle volume measurements near the study sites could have improved the accuracy of regression analysis and provided more reliable insights to traffic PM 2.5 variation. Then, technical challenges led to gaps in the collected data, which resulted in some missing information for certain periods during the study timeline, as the Wi-Fi network and the electrical outage were a significant hindrance in collecting our data. Thank you so much. If you have any queries, please contact us in the given email address. I have also provided the email address in the Zoom chat. Thank you so much.